There is a dog asleep somewhere near you right now. On a couch, on a bed, on the floor next to your feet. An animal that 15,000 years ago was a wolf. An apex predator with a bite force capable of crushing bone, a social hierarchy built around dominance and aggression, and absolutely no interest in living inside a human home. And yet here it is, asleep on your couch. Domestication is one of the strangest things humans have ever done, not because it required technology or planning or any particular burst of intelligence, but because it required something much harder to engineer, the right animal. An animal with the right social structure, the right cognitive flexibility, the right metabolic needs, and the right relationship with fear. Change any one of those variables, and the wolf stays a wolf. It never becomes a dog. It never learns its name. It never chooses every single day to stay. Now think about a dinosaur. Not the cartoon version. Not the Jurassic Park version. The real animal, a creature that spent 165 million years at the top of every food chain it ever entered, shaped by evolutionary pressures that had nothing to do with cooperation, nothing to do with coexistence, and nothing to do with the kind of trust that domestication requires. Could we have done it? Could we have taken something from that world and turned it into something that lived with us, worked with us, maybe even chose us? The answer requires understanding what domestication actually is. And once you understand that, the dinosaur question stops being about courage or technology. It becomes about biology. And biology, in this case, is almost entirely uncooperative. The obvious image is the dramatic one, a human taming a T-Rex the way a lion tamer tames a lion. Willpower and a whip and enough repetition to override millions of years of instinct. But that's not domestication. That's captivity. And the difference between those two things is the difference between a tiger in a zoo and a cat on your lap. Both are technically controlled. Only one of them chose to be there. The real question isn't whether humans could have forced a dinosaur to comply. With enough technology, enough enclosure, enough behavioral conditioning, you can get almost any animal to perform. The better question is whether any dinosaur species possess the specific biological and behavioral prerequisites that domestication actually requires, and whether, if those prerequisites existed, the relationship could have become something mutual rather than just managed. That question has a specific scientific answer, and it starts not with dinosaurs, but with the 6 animals that humans have successfully domesticated in the entire history of our species. In 1997, evolutionary biologist Jared Diamond published an analysis in his work on human societies that has since become the foundational framework for understanding why domestication succeeded with some species and failed with nearly every other. Diamond identified what he called the Anna Karenina principle of domestication. Just as Tolstoy wrote that every unhappy family is unhappy in its own way, every undomesticatable animal fails for its own specific reason. But every successfully domesticated animal succeeds for the same set of reasons. Diamond's criteria were precise. A domesticable animal must have a flexible diet, ideally omnivorous or herbivorous, not a specialist predator requiring live prey. It must have a rapid enough growth rate to be economically useful within a human generation. It must be capable of breeding in captivity, which many large animals refuse to do under stress or confinement. It must have a social hierarchy, that humans can insert themselves into a dominant structure where the animal accepts a human as a higher-ranking member of its group rather than as a threat or a competitor. And, critically, it must have a nervous system that responds to stress with submission rather than with panic or aggression, what behaviorists call a low flight distance, the threshold at which an animal runs from a perceived threat. Of the roughly 148 large terrestrial mammal species that existed when humans began domesticating animals, only 14 were ever successfully domesticated. The rest failed on one or more of Diamond's criteria. The zebra looks like a horse and lives in the same ecosystems as donkeys that were domesticated thousands of years ago, but zebras panic under restraint, bite without releasing, and have a flight distance so high that sustained captive breeding has never been achieved despite centuries of attempts. The grizzly bear is intelligent, omnivorous, and demonstrably capable of forming bonds with individual humans, but its unpredictability, under stress, and its refusal to breed reliably in captivity has kept it permanently outside the domesticated category. Now apply those criteria to dinosaurs. Start with diet. The large theropods, the animals most culturally associated with dinosaurs, were obligate predators, not flexible omnivores, not animals that could be sustained on grain or forage. Animals that required large quantities of live or freshly killed prey to meet their caloric needs. A T-Rex, based on estimated metabolic rates, would have needed to consume roughly 11 kilograms of meat per day at minimum, and likely significantly more during growth phases. Sustaining a captive population of large theropods would have required a parallel system of prey animal husbandry so large and resource-intensive that the energy cost alone would have made the enterprise economically impossible for any pre-industrial human society. Now think about the stress response. Domestication requires an animal whose nervous system, under the pressure of confinement and human contact, moves toward accommodation rather than escalation. The domestication of dogs almost certainly began with wolves, whose cortisol response to human proximity was lower than average individuals who didn't flee, didn't attack, and eventually tolerated closeness enough to scavenge near human camps. That tolerance, selected for over thousands of generations, produced the dog. The theropod stress response was shaped by 165 million years of being at the top of the food chain. There was no evolutionary pressure toward submission, toward tolerance of proximity, toward the kind of reduced fear response that domestication requires. The animals that survived in that world were not the ones that stayed calm near large, slow-moving creatures. They were the ones that acted. But here's what's really interesting. Not all dinosaurs were theropods, and not all theropods were large. Consider the ornithomimosaurs, the ostrich-mimic dinosaurs of the late Cretaceous, animals roughly the size of a modern emu, bipedal, fast, probably omnivorous, and living in social groups. Their body plan, their diet, and their social structure are far closer to the profile of a domesticable animal than anything in the theropod predator lineage. We have, after all, domesticated the ostrich, an animal with a kick capable of disemboweling a lion, a brain the size of a walnut, and a temperament that makes it one of the most dangerous domestic animals on the planet. If we domesticated that, the ornithomimosaur is not an impossible candidate. Consider also the hadrosaurs large, herding herbivores with complex social structures, vocalizations suggesting sophisticated intra-group communication, and the kind of herd dynamics that humans have exploited in domesticated cattle, horses, and sheep for thousands of years. A hadrosaur's social hierarchy would not have been trivially penetrable by a human, but it was a hierarchy, and hierarchies, unlike solitary territorial behavior, at least offer a structural foothold for the kind of relationship domestication requires. The problem in both cases is scale and the breeding criterion. Hadrosaurs reached lengths of 9 to 13 meters and weights of 3 to 4 tons. Sustaining a breeding population in captivity would have required infrastructure that no human civilization has ever built for an animal of that size. And captive breeding for hadrosaurs would have meant managing nesting behavior, incubation, and juvenile care for animals whose eggs and hatchlings would themselves have been resource-intensive to protect. There is one case that comes closest to plausible. The small feathered theropods of the late Cretaceous animals in the 1 to 5 kilogram range, probably omnivorous, cognitively sophisticated relative to their body size, and living in social groups. We know that one lineage of exactly these animals was domesticated. We eat their eggs every morning. The chicken is a domesticated dinosaur. The domesticated dinosaur already exists. It just isn't what anyone imagines when they ask the question. But here's the thing. The question we started with, could we have domesticated a dinosaur, was really asking something else. It was asking whether we could have made something ancient and dangerous into something familiar, something we could name and feed and trust. And the answer the science gives us is the same answer it always gives when humans ask whether they can control something larger and older than themselves. Sometimes, under very specific conditions, with very specific animals, if we're patient enough and the biology cooperates. We domesticated the wolf. We domesticated the wild horse, an animal that ran from everything for millions of years. We domesticated the cat, which is debatable whether it was us doing the domesticating or the cat deciding entirely on its own terms that humans were useful. What we have never done is domesticate something that didn't at some level have the capacity to choose proximity. Every domesticated animal made a version of that choice, generation by generation, as the individuals most tolerant of humans survived and bred and passed that tolerance on. Domestication is not something we do to animals. It is something that happens between us, across thousands of years, requiring cooperation from both sides. A T-Rex would not have cooperated. A hadrosaur might have tolerated us in the way a bison tolerates a cowbird. A small, feathered theropod, under the right conditions, might have done exactly what the red jungle fowl did, moved gradually, generation by generation, closer to the fire. And one of them did. There is something worth sitting with in the fact that we already share our lives with a dinosaur, That the animal we domesticated most successfully, the one that feeds more humans than any other domesticated species on the planet, the one whose eggs appear on every continent, in every culture, in every economic bracket, is a direct descendant of the theropod lineage that once included the largest predators that ever walked the earth. We didn't tame the monster. We tamed the one that was already moving toward us. That is how domestication has always worked. Not conquest, not force. A long, slow, mutual approach across thousands of years, ending in something neither side fully intended, and something neither side, by the end, could easily do without. The dinosaur is already domesticated. It's in your refrigerator.